Kia ora, Year 9. In this video, I'm going to look at how to find the area of 4 shapes. Right, so I'm going to work quite quickly through this, and I'm going to be using formulae. Now, in class, we'll do a bit of investigating where these formulae came from, but it's a bit hard to do that over a video. So this is a skills video, and once you've watched it, you should be good to practice the Dr. Frost work that I've set. I'm just trying to draw the fourth of those shapes. There we go. Right, so you'll know most of these already. The rectangle is this first one here. It's a rectangle because it's got right angles in all the corners and 2 sets of parallel lines. This is a triangle. They come in lots of different versions. We're going to have a look at that later on in this video, and we know that from our geometry unit already. This shape here is the parallelogram. It's called that because it's got 2 sets of parallel sides. So we can see those 2 are parallel. And then we can see that those 2 sides are also parallel. So that turns out to be really, really easy for finding the area of that shape. Okay, and then the last one is the trapezium. And the trapezium's got 1 set of parallel sides. Oh, it's disappeared. Hang on, I have to get my trapezium back. There we go. So that's my trapezium, and we can see in there that that side and that side are parallel, and the other 2 sides just join those 2 up. So I'm going to show you now a table of formulae that we're going to use for finding the area of those 4 shapes. Now, don't worry, you don't have to memorize those straight away, but you'll find that they're pretty easy to learn because they make quite a lot of sense. Right, so the first one, the area one, most of you will have been using that at primary school. Sometimes students will tell me that they learn it as the length times the width, and that's totally fine. That's what I usually say as well. But the reason I've written B and H in here is because for all of these shapes, I'm going to use B for the base and H for the height, and they come up in all of these area situations. So for a rectangle, we just take the base and the height and we times them together. So the base is here and the height is here. And we can see that the height is forming a right angle with the base. Okay, so that's important. We'll go on to some examples shortly. Oh no, actually I'll do an example now. So suppose the base is 10 centimetres and the height is 6 centimetres. Then the area is equal to 10 times 6, which is 60. And my units will be centimetres squared. So we just write the units in at the end, but it's really important we remember to do that. Okay, let's look at triangles now. So when we've got a triangle, we're going to call this here the base. Now what about the height? Well, we saw when we did the rectangle that the height gave us a right angle with the base and went up to the top of the shape. And we're going to use that idea for our triangle. So the height is going to be a line that goes from the top down to the bottom, but it has to be the line that gives us a right angle with the shape. So it's this line here that forms a right angle. That's the height. Not this side and not this side and not some weird thing in the middle. Okay, so the height has got to give us a right angle with the base. And I've put that in here with the table. Okay. So for this triangle here, if the base is 10 centimetres, we have to be told the value of the height to find the area, at least so far with what we know in maths. So the area of this triangle will be a half times 10 times 6, which is going to be 30 centimetres squared. Now I can't help telling you where that comes from, and I'm going to show you with a ruler. If the reason that we end up with half the base times the height is that we could think about drawing in, preferably in a different coloured pen. Let's try that again. There. We could draw a rectangle that's formed around that triangle. Okay, and so if I do that, what you'll see is that that rectangle has got a height of h and a base of b. And the triangle inside it is exactly half of that rectangle, right? You can see that yellow bit there is half of the square. And then let's do a different colour here. This bit here, this triangle bit here, is half of this bit here. So that's where that formula comes from, right? The triangle area is half the base times the height. Right, let's go on to a couple more triangles just to make sure we've really got this idea of where the height is. So the base is here. So the height here, we start at this point here, and it must be this length here that forms a rectangle with that side. So if the base is 12 centimeters, and this is, I don't know, 4 centimeters, then the area will be a half times 12 times 4. So that's 6 fours, 24 centimeters squared. Let's look at this one. I put this one in on purpose because there are a couple of ways to think about this weird looking triangle. So this is, I'm going to make this side here my base, and then I can hear you going, but where's the height, right? So here's the top bit of the triangle. So it's the same idea. We just drop down a line that would form a perpendicular if we extended that base out like that. So that's going to be my height, and that's going to be my base. So if my base is 6 centimeters, and my height is 5 centimeters, the area is still going to be a half times 6 times 5, which will give me here 15 centimeters squared. The other way that I could do that is that I could change how I'm doing the base. So it will depend on what information I'm given. So we can do that thing where we extend the base, or let's just get that triangle back. Didn't like it. Let's draw a nice triangle. Still not liking it. Okay. Right. Okay. I've got my triangle back. It's not quite the same one, but it will do. So things that we could do here is we could extend this side out to find my height. Or if I were actually doing this in real life and measuring, the other thing that I could do is I could turn it around. Well, let's see if I can turn it around. I think I probably can. Let's see. No, I can't. Well, we'll just do it the slow way. So here we could make this the base along here, and then we could make this the height here, and it will all work out the same. And we'll try playing around with that in class. Okay, so that's area of a triangle done, and we've got 2 left. Well, the parallelogram is really, really easy as long as we remember the same thing with the height. Here's my parallelogram. The height has to go from here down to here. That's my height, and this is my base. So if the base is 8 and the height is 6, the area of the parallelogram is simply 8 times 6, which is 48 centimeters squared. Now, the way to see why that works is if you look at how I've drawn that, we can see that if I just colour in this triangle here, we could chop that off and we could stick it in here, and it would fit exactly because the sides, we've got 2 sets of parallel sides. So that's why the area is the same as the formula for a rectangle. Now the last one is the trapezium formula. Now this looks daunting. There are a couple of ways, well, not daunting, but just a bit worse than the other ones. Sometimes you'll see it written like that. Sometimes you'll see it written like this, which is the same thing. I prefer to see it written like this, and here's why. All we do to find the area of a trapezium is that we look at our 2 parallel sides. We call this one here B for the base, and we call the parallel one to it up the top A, right? And then, as usual, H is the perpendicular height. So what we're doing to find the area of a trapezium is we're taking these 2 numbers. So suppose this one is 6 centimeters and this one is 10 centimeters. And we're just taking the average of those 2 numbers. And then we're timesing them by this. Oh, something bad just happened, guys. Okay, my OneNote just shut down. I think that's because my laptop's running out of charge. Let's see. Oh no, we're still good. Okay, so H here, we'll make the H equal to what? Let's make H quite little. So make H 5 centimeters. So suppose that that's what we've got. Well, we've got A is 6, B is 10, and H is 5. So we're substituting them into this formula. So A is equal to 6 plus 10 divided by 2. times 5. So 16 divided by 2 is just 8. And that gives me an area of 40 centimetres squared. Or you can do this. 1/2 of A plus B times H. It's exactly the same thing. So we've got half of the top and bottom sides, or the two parallel ones, times the height. So it's 1/2 of 16 times 5, which again gives me 40 centimetres squared. So there you go. So that's quite a long video. What I want you to do to finish off is just into your book. It would be good to get some decent notes down on these. So I'm just going to clean this slide up a tiny bit. Can you just copy this down into your book? I'm just going to put a big box around what I want you to do. So that bit there, copy that. And then I also want you to write down this bit down here, because this is also important. Okay, so once you've done that, then you should be good to go with quite a few different skills practice exercises on Dr. Frost or using the textbook in class. Thanks for watching.